Hello, New York State Economics Association. Just in case the presentation software doesn't work, I decided I'd better record just a quick demo of the model that I'm showing today, just to be safe. Or if you're coming to this later, you didn't see my presentation, you'll see a little bit of what's going on. So, if you want to follow along at home, use NetLogo. There's a link in the presentation. And when you load this model into here, you'll see the documentation that gives you sort of the blow-by-blow of what's going on in here. And of course, you can go through and read the code and get an idea of what the specific mechanics are. But we're not going to worry about that today. Let's just focus on the thing as it is. So we've got this little world of all these little agents. They're called turtles in NetLogo. So these little turtles, we can look at turtle number 126 and we can see what's going on with them. So on the screen, we've got a bunch of sliders so we can change the parameters of the world. We've got stuff about randomness, which we'll just leave alone for now. We've got the prisoner's dilemma payouts. This looks about right. Yeah, that fits the prisoner's dilemma. So we could change this and have something that's not a prisoner's dilemma. But basically, we've got a 2x2 game and the payouts for each square that we can alter here. And then we've got some things that alter how complex or how costly it is to be complex for each of these agents. So the complexity takes the form of their strategy. And their strategy tells them what to do under certain circumstances based on the history that they have seen so far, what they have done, and what they've seen their partners do when they've played Prisoner's Dilemmas in the past. Now, initially, we just throw a bunch of ones in there. In this case, we've got an empty list for partner history. They haven't played yet, but we initialize them with this idea that they've been cooperating just to kind of bias things in that direction. And of course, we could alter that as we want to. So complexity, costs, and then some sliders to do with the genetic algorithm, how we determine which turtles procreate and which ones die off. And this is really the secret sauce to this model. We have these interactions, and how successful they are at the prisoner's dilemma determines what goes on in the future. So let's have them run through 5 rounds. And then let's ask to inspect turtle 126 again. So here's 126. They've had some interactions now, and now their history has been overwritten with uncooperative outcomes. So they have not been seeing a pleasant world so far. We can also hit the show strategy count button so we can see the different strategies that have been playing out. Now, I should have showed this before I started, but we've got a few simple strategies here. These ones with just 2 bits of information. Then we've got some more complex ones that are twice as long. These are agents with twice as much memory. They can remember 2 moves back rather than 1. So these guys basically look back and see, what did my partner do last round? These guys look back and see, what did my partner do last round and what did I do last round? And that allows for more sophisticated behavior. And if we keep going, we will get more and more strategies. We will see mutations. We'll see, in this case, the population changes. We get some new strategies introduced. Some die off. And we can watch how that changes over time. Now let's go back and see if we can look at turtle 126 again. Turtle 126 has died. They weren't cooperating enough. They no longer exist. So when we look at what's going on with the turtles that are there, we're seeing them succumb to the pressure of their environment. And ultimately, we're going to see these strategies move in a direction that fits that environment. Now, I'm going to leave the video here just to not take up too much time in the presentation, but I would encourage you guys to check out my GitHub repository, download NetLogo, play with this, and share what you find. All right, thank you very much, and I will talk to you in the question and answer period.